We're going to go and drink from the fire hose now with Dave Nicolation and hear about new technology. And we're all going to be thinking about how you're going to make this work, Dave and Brian and others, because it sounds good. And it also bridges us into the final session, which is on nature-based solutions. If you're wondering about the agenda, we're going to steal we're going to push the break and we're going to steal from the closing. Okay, so we're still going to wrap at 12:30, but the closing is going to be nice and short. Okay, so thanks very much, Dave. And if you guys could introduce yourselves, that would be awesome.
Great.
Thanks,
everybody. I'm just going to do like a 2 or 3 minute intro here to kind of set the stage, and then Grant's going to do the technical part of this, and he'll introduce himself. For those of you that weren't here yesterday, and Dave Nicolation, and I have two employers. One is McCarthy Tetro, and I'm part of the firm here. I also do business development work for Brian Fair Group, which is where this falls under. And so the stage setting I wanted to do here was yesterday. For folks that were here, you would have heard Hydro talk about their load forecast. And one of the things they talked a lot about was, the need for firm capacity and the difference between a lot of the intermittent sources they're bringing on now, which is a lot of the wind projects in the power calls, and the fact they're running out of firm projects. For example, they talked about, adding another generator at Mica, and there's very precious few of those left without building another big hydro dam somewhere else. Pump storage was mentioned as a possible solution for firming up power. But one of the things we're going to talk about here is biomass. And what's interesting about biomass power is how it came to be in BC and actually elsewhere is it very much is a firm, dispatchable source of capacity and energy in an energy system. But BC's experience hasn't been that great, because the traditional biomass power plants we have in BC are usually tied to a operating sawmill. So it takes residuals, the waste from a sawmill operation, and burns it in a power plant and produces green energy that way. But the problem is, historically, at least, when the sawmill goes down, the power plant goes down. So if you're BC Hydro and you're contracting for firm power, that's a big problem, because you pay more for firm power and you expect it to be dispatchable. And then if it's not, because the sawmill goes down, that creates a big energy planning problem for hydro. So one of the things that we did here, and you're going to hear about, is we participated, and when I say we, there was about 10 First Nations participated in an exercise to think about a new way to design and build biomass power. And we pitched this idea into the BC Hydro Request for Expression of Interest that they did last fall for firm capacity. And there's lots of interest in what you're about to hear about, because it solves for that problem of firm, how reliable biomass power can be. So you're going to hear about that from Grant. But it also has the big advantage of being part of a bigger policy story for BC. So if you think about the Venn diagram of three very, very important policy domains that the BC government's fussing with right now, one is, we heard about yesterday, they need a lot more energy. We heard about, data centers, yada, yada, new LNG, all the things we heard about, they're going to need a whole bunch of new energy for. So you got the energy circle. You've got the forestry circle. So forestry in BC is really on its knees. And you saw the projection Hydro put up yesterday that they're predicting the demise of the forestry industry. There's going to be no new mills or pulp mills or any of those things. And so that's a big problem for your number one industry if you're the BC government, historically number one industry in this province. And so there's a lot of thinking going on. What can we do as policymakers in the BC government to help that problem? How do we help forestry get off its knees? And that crossover in the Venn diagram between the business case that you can feed into a new sawmill by having the owners of that mill also own a bioenergy facility is very, very interesting, and the economics are very good. And then the third circle in the Venn diagram is First Nations reconciliation. So, I'm a big believer that all of the above should be owned and controlled and managed and operated by First Nations. So First Nations should control the forest tenures. First Nations should own those sawmills, those new modern sawmills. They should own the residuals from those mills, and they should own the bioenergy facility, and they should own the EPA with hydro. And the business case for all of that is self-reinforcing. And so there is an active conversation going on in the BC government right now to say, are we capable of managing, these problems and that, thinking about these historically ships in the night policy areas as one big opportunity. So with that, I'll turn it over to Grant to talk about what we're actually up to. So.
Thanks, Dave. Thanks for having me here. We'll just start with a bit of an outlook on British Columbia, and I think I'm probably revisiting something that was maybe presented yesterday by BC Hydro in terms of the demand for electricity in British Columbia. So we'll kind of set the stage to talk about the electrical markets in British Columbia, and then we'll discuss how sawmills can play a role in solving the problems. So we have a rising demand in BC, as David talked about, increasing vulnerability from BC Hydro's reservoir network, especially in the months of, say, January, February, when reservoir levels are low. New industries are coming into British Columbia, we hope, generating new demand, and BC Hydro has to meet these demand requirements. So there's a requirement for clean, firm, dispatchable power. Again, BC Hydro's own estimates, 4,000 gigawatt hour energy shortfall. That was a 2023 projection. And we can see the shortfall is rising, not decreasing. BC Hydro's own demand forecast was revised from 2021 to 2023. So again, rising demand. We did lose some capacity, as David alluded to, in British Columbia. We lost a few of the biomass power generation facilities, again, related to sawmills and the economic situation and sustainable growth or harvesting area for these sawmills. And we need roughly 3,000 gigawatt hours of new greenfield clean energy to meet the requirements. And the timeline is fairly urgent. So there's a significant gap, as you saw from the previous graphs, as we go forward. So this projection from Hydro from 2021 indicates a deficit after about 2032. So there's a window of opportunity here to create some new generation. At the same time, we have to deal with the sawmill industry that has significant challenges, both economically and from a policy standpoint. When there is a shortfall, BC Hydro, although we have one of the cleanest grids in North America, we have to rely on imports. We can't always assume that the imported electricity is going to be carbon neutral. Making the point here, we need dependable power. It needs to be renewable, ideally, or low carbon. And then we'll take it back to the sawmill. So when we talk about a sawmill in British Columbia, the log itself, roughly 40 to 50% of the log volume, of the timber volume is turned into merchantable timber. That leaves 50% where we have to find a home for the sawmill residuals, whether it's pulp chips, planer shavings, sawdust, trim ends. So that's the challenge for the sawmill folks. They have to find a home for all these residual fibers. They can't just let the fiber accumulate on the site. 50 years ago, you would run a beehive burner to take care of the residuals. The ideal situation is you've got a pulp mill next door with a short transportation distance. You're getting good revenue from your pulp mill. But pulp mills are few and far between, and we just lost another one this week, as we heard in the news, the Crofton pulp mill. So it's a challenge for sure for these sawmills. Some of the other homes for the residuals would be pellet plants. So there's been a growing export market for pellet plants. To take that fiber, compress it, firstly dry it, then compress it, and then transport it to other markets. But what happens if there's a policy change, or what happens if the pellet plant is down for some reason, or perhaps there's a sawmill that goes down and now the pellet plant is unviable. So there's an operating risk for all of the sawmills. They're really exposed to policies in other markets, and it's an operational risk. So residuals that maybe once are generating money are now going to cost to actually operate if they have to find markets, and in some cases the sawmills are no longer viable. As David talked about, we focused a recent study for the northwest of BC, specifically along the Highway 16 corridor, where we took a look at the fiber supply and what could be possible when we married up bioenergy in an optimized format with modern sawmill technology. So some of the challenges in northwest BC, fairly far from residual markets. The nearest pulp mill is Prince George from this area, so that's a fair transportation distance, certainly far away for places like Terrace. Terrace has traditionally, they used to have a pulp mill there. That's been closed for many, many years. The only other outlet for the chips, if you're operating a sawmill in the Terrace region, is to transport the fiber through tidewater down to lower mainland markets. But it's a long transportation haul, and it's a question of, is there any residual value left in the fiber by the time you get it to the market? So no local pulp mills. There was a pellet plant in the Terrace area, but it's been shuttered. So this intertie between sawmills and the offtakes for residuals between the pulp markets and the pellet plants is tricky, and it depends on where the plants are located. So if we can come up with a consumer for all these residual streams that adds value to the sawmill and reduces the exposure to transportation, to policy, to other markets. And if we've got a reliable off-taker, that off-taker being BC Hydro. So without local power generation, again, we talked about your residuals have to be transported long distances. Sawdust and shavings end up having minimal or even negative value, but the sawmills are forced to absorb those costs in order to keep running. The bark can often accumulate as waste. It can create fire hazards, which doesn't make the insurance companies happy. And it's a lot of risk to operate these mills if they're going to let the residuals sit on the ground. And you're increasing the risk of a mill closure. If we can come up with a power generation facility that can take care of these residuals and add value to the sawmill, then the economic haul radius of a sawmill is dependent. We hear this in the news about sawmill closures, where they often cite unavailability of fiber. But really, fiber, if they're getting high value from the fiber, then the economic haul radius is much larger. So when we read this in the news about, well, they couldn't get fiber, what it really means is they couldn't get economical fiber, and that's all comes back to the economics. Can you afford to transport fiber from a long distance because you've got a good technical solution that can generate some revenue for the plant? So some of the traditional solutions for sawmills generating electricity, and just a little bit of my background. So we've spent the last 20 years designing bioenergy systems for sawmills and facilities in both Canada and the United States. And we've taken a look at all different technologies. We were lucky enough to be involved in the first bioenergy organic Rankine cycle project in Canada. That was actually in Vanderhoof in 2011. And it won some funding from government, just to touch upon what we were talking about in the earlier discussion. So it is important to get that seed funding to get this technology to work. But at the end of the day, the electrical efficiency of an organic Rankine cycle bioenergy plant is around the 20% region. They can also generate significant heating, where you can be drying lumber using that as well. So it's still a technology that works, but it doesn't generate significant revenue And the pricing, the dollars per megawatt for biomass using organic Rankine cycle is somewhat expensive today, around $170 a megawatt hour to be economic. The technology we're going to touch on here has a much higher efficiency in this unique configuration, much higher than ORC, and that was kind of the genesis behind this, is how can we generate more value for the sawmill for every ton of residual that goes into the plant. Yeah, again, I mean, we're calling it a hybrid technology. So biomass to ORC, as we talked about, it's a 20% electrical efficiency, fairly high cost per megawatt, but with some nice benefits. You're getting rid of all of the residuals. Again, it does rely on a long-term off-take agreement in order to get funding. We've been involved in a lot of funding and what it takes to get funding on plants. And so you need fiber and you need off-take agreements, as some of our previous guests talked about. Biomass to steam. So this is a traditional technology. It's been around for probably 100 years in the sawmill industry. It definitely works. We've been involved in some biomass to steam type plants. The minimum economic size for a biomass to steam plant is probably 30 to 40 megawatts minimum. And part of that is just the complexity of a steam plant, the capital cost, but it's mostly the operational requirements, the requirement for first-class steam engineering supervision 24/7. That's a significant investment. So if you're below 30 megawatt in Canada, certainly in British Columbia, you'll struggle to be profitable. And also the fiber haul radius for a 40 megawatt plant is a large radius plant and significant transportation distances, because a single sawmill cannot supply enough biomass for a 40 megawatt biomass to steam plant. So this kind of creates a gap. ORC is a bit too small, and standalone steam is a bit too much fiber. It's actually quite a bit too much fiber for a single sawmill. So no good standalone option existed. So we asked the question, if you could reach utility scale, say 100 megawatts with fiber from a single sawmill, is this possible? And we looked at combining natural gas fuel type with biomass. And in the configuration we're talking about, it achieves an efficiency of around 48%, can even be higher if we go to very exotic steam pressures. And this is using the steam cycle. And we'll take a look at the carbon intensity of this technology. So traditional coal, we're at 900 grams of CO2 equivalent per kilowatt. Simple cycle gas, 500. This integrated hybrid biomass solution is around 200 with a carbon capture on the back end. And roughly 50% of the energy into this is from biomass, and the other 50% of the energy comes from natural gas. So you end up with a power generation technology at scale, so 100 megawatts, with roughly half of the carbon footprint of traditional natural gas. There's some other advantages with the exhaust characteristics of this plant. You're combining a typical natural gas from, say, gas turbine generation has roughly 3 to 4% CO2 concentration. So if we're talking about carbon capture from natural gas power generation, the low CO2 concentration really drives up the cost per ton for sequestering the CO2. Biomass has an advantage. It's biogenic carbon, for one. Secondly, it's much higher concentration when compared with natural gas, simple cycle turbine combustion in terms of CO2 concentration. So right away, you're at a more economical case in terms of the CO2 concentration from the flue gas. If we were to capture, say, 80% of the combined emissions from this plant, most of the captured CO2 is going to end up being biogenic, which could be sold at a premium potentially. So this cycle with carbon capture and storage, and we know that's in the future, but it's certainly capable of being added on to the cycle at a later phase, especially once networks for carbon capture and storage are developed, hopefully. So we end up with firm dispatchable, and we looked at for this latest expression of interest for capacity for BC Hydro at 100 megawatt plant size, because it matched up with the fiber for roughly about a medium-sized sawmill, right around the 200 million board feet per year. And we touched earlier about biomass, and David talked about this as well. It's a firm product. It's firm. It's dispatchable. It's distinct from wind and solar, especially in the wintertime. And that was also identified in BC Hydro's request for expression of interest. They were definitely looking for firm power in the wintertime specifically. Capacity factor is quite conservative at 85%. We have biomass plants that have been 94% and better year after year. So we meet the definition of firm power. So in summary here, so it's designed for BC. We targeted BC Hydro's needs, and we tried to match up a solution that also worked for the forest industry. So one facility and two problems solved. Just a bit of a summary. We're not going to provide a lot of detail on the actual cycle. It is the subject of a patent application. And if anybody has specific technical questions, probably have to do an NDA to get into real detail. Yeah, I think we'll just summarize. So taking two energy sources, providing firm power. The target is a base load energy with a low emission footprint and tight integration with the sawmill. So it has to be a solution that really works for sawmills. And we're lucky enough to have worked with enough sawmills over the years. It's given us a good understanding of what can work for a sawmill, combined with what BC Hydro requires for offtake agreements. I think that's it.
Awesome. Thank you so much. Questions?
So just curious, thank you very much for the presentation. Just when we're adding the CCS to this facility, you had quoted the 200 grams per kilowatt hour as your carbon intensity, I think, right? And so that would assume that the biomass has a net zero.
That's right.
So we're talking about basically the gas.
That's right.
Yeah. Okay. So, and then if you go ahead and capture the CO2, is the 200 number assuming that doesn't include the carbon capture component? So what would it look like with the CCS bolted onto that thing? Are we going negative?
We could go negative.
Yeah.
Absolutely.
Yeah. Okay. So, because I think that would be an important point to make in your presentation, that you might end up with a negative 100 grams per kilowatt hour type facility, which
Absolutely.
is really important. Yeah.
The whole idea here is to also hit the number for hydro, right? So that's the real question. It keeps coming back to something we've discussed at several of these presentations. Is there a price for carbon? Can you sell those attributes? And do you impute who benefits, hydro or the developer? And how do you split? Like those become those considerations. And then, but the beauty of this whole idea is you can build it. And if the sawmill's running per the design we have, we stay below the emissions threshold for paying carbon tax in BC. So the overall profile of the emissions, even though it's hybrid solutions with gas, stays, within the Clean BC targets would be the design parameters. And then optionally, depending upon all the answers to those questions I asked a minute ago, you can capture you can mount CCS on here. And of course, it's always that trade-off between what's the CCS, what's it cost to do the capture? Are you in a place where you can actually sequester it, or do you got to move the CO2 now? Who's selling those attributes for how much to which benefit? But the optionality here is kind of the point. It's not like pathways, which we talked about earlier, which is one-dimensional, right? And it's bigger, like its own, because this we think is going to be in the money for selling, getting an EPA with hydro at the current price hydro is willing to pay for firm energy. You can do this, and then if you want to make it greener, you can. It's kind of that optionality.
Thanks, David. Thanks, Grant. Grant and I belong in the same industry, and we both have been part of getting rid of beehive burners. When I started working in BC, and Grant as well, there was something like 76 beehive burners, and I think together the two of us have got rid of about 48 of them or something like that. And so it's been fun to work together. And Grant, I think you're missing, you basically talked about three solutions there. One is for BC Hydro, one is for the sawmill industry, and one is for First Nation reconciliation. And the one you're missing is forest fires. We have a huge problem. We burnt something like 18 million cubic meters of fiber in Fort Nelson. That's bigger than than Vancouver Island. And nobody knows. Nobody even recognizes it. As I travel around, they're like, what are you talking about? But we have a huge problem, especially in the north with forest fires. And if we could have 3 or 4 of these plants at 100 megawatts or bigger running, that really, really solves a lot of that, those piles that are left in the bush and the stuff that's left in the bush that isn't economical. And what it does really well is burns. And so I sure like that as far as another solution for forest fires as well.
Yeah, it's a really good point. It's a really good point. And we talked yesterday, somebody mentioned that Crofton went down a couple days ago, the latest pulp mill in BC to go down. The other thing to think about is, we've talked a lot about sawmill residuals, and that's what this whole presentation's built on. But what is going to happen to all that pulpwood out there? I mean, right now, from an environmental acceptable standpoint, it's perfectly okay to go harvest pulpwood, chip it up and turn it into pulp and paper. Well, and what's going to, it's the point Brian just made. Like, all that pulpwood out there could find a home as well in a system like this. Questions?
Okay, so what's stopping you?
I think like I said in my intro, it's actually early days, but it's actually Hydro is interested. Like, the good thing Hydro did was stimulate the conversation by asking, like, what's out there for options. And like we heard yesterday, people bid batteries, they bid pump storage. Well, we bid this. And so Hydro right now is looking to say, okay, well, what's that going to look like? Because they're out of big hydro dams to build, so they got to do something. And right now, in absence of those green options, they're going to build more gas-fired power plants. It's the only thing they got left. Until nukes come along, they're going to build more gas. So the real question they're pondering is, are these ideas legit? And I'll tell you where it's going to come down to, whether it's batteries or biomass or whatever, the first question they're going to ask is, how much does it cost? What's a megawatt hour of energy cost? And then I'll tell you how much I like it. All right. And so that conversation is just starting. So I'm trying to answer, I'm giving you a long answer, but I think Hydro is going to be pushing more and more of those conversations to, people who made submissions to say, tell me more and tell me more. And eventually you're going to see a power call, and that's when it'll take off. So I predict within the next couple of years, you're going to see instead of just a wide open energy call, which is what they're doing right now, where these wind farms are being bid in, they're going to have a power call for firm power. That's what I think they're going to do. And then all these ideas can bid in, and then you got to put your money where your mouth is, if you're us or the battery guys or whoever, and then we'll see what happens. But I think it is happening, actually.
So if we have a cost of $80 a meter for a burnt log out of the bush with all the costs, and $4 for nat gas, what do you think that's going to come in at per megawatt hour?
Yeah, actually, in our modeling, I believe, David, correct me if I'm wrong, I think we modeled 110 for our fiber cost. very conservatively because we wanted to prove this concept out in a market in terrace, actually, which doesn't have all the residual offtakes and has high logging costs. So we, on purpose, and we worked with foresters to identify the fiber basket to begin with. We're very conservative with our economics.
That submission we did to Hydro, we modeled two areas. We modeled the Terrace area and the Houston area, and we worked with Meraki mostly for the fiber study costs, delivered log costs in the Houston area, and then we worked with Fortec in the Terrace area, and we as Grant just said, we purposely made it a worst case kind of scenario just so we could drive out the worst case high end dollars per megawatt hour. And, it depends on so many things, but you're south of $15 or 15 cents or $150 a megawatt hour. I think we're out of time.
Yeah. Well, thank you. I just want to say one thing about this, which takes us back to Wes Sam's comments yesterday. I don't know, not everybody was here, but those of you that were, remember, he said it's all about cooperation and collaboration. And if you go from Terrace to Houston, you're basically in the territories of all the Wet'suwet'en and a good chunk of the Tsimshians and Haisla, maybe Niska. So if all those nations worked together and decided that they wanted to do this, it would be unstoppable, potentially. And that's what I think it was, how many nations were? 10. So 10 out of those nations signed on to the proposal that was submitted to BC Hydro. And if they decide that this makes sense and they can work together, they can make this happen. Okay, we're going to take a break. Thank you very much, Dave and Grant. And to the previous panel, that was a great segue into, we can see how these new technologies can really help us, but making them work, paying for it, paying for the transition, and having the collaboration that's necessary to make them real are challenges that we're learning to overcome. Brian's comment about wildfire was the perfect part of the segue into the next panel discussion we're going to have after the break, because nature-based solutions are becoming more and more about biomass management and fire risk reduction. So when we come back, we're going to have the last panel, which is going to feature a number of different speakers that are actively involved in nature-based solutions. So, and we'll still be ending at 12:30, 12:35 for lunch. Okay? So thanks very much, and we'll take 10 minutes.